Today, we are going to go under the hood of an absolute legend, the Commodore 64. And we're not just looking at old games, we're diving into the secret language that made them possible. A lean, mean, and just unbelievably efficient language called assembly. This right here is the key to understanding how these epic worlds were built with almost no memory to spare.
For so many of us, this blue screen was, well, it was everything. Ready. It looks so simple, right? But behind this welcome was a whole universe of raw potential. It was a machine that developers could speak to directly, forcing every single byte to perform absolute miracles.
And that really is the big question for today, isn't it? How did they pull it off? How did they create these massive sprawling worlds and fast-paced action on hardware with just 64 kilobytes of RAM? The answer, you see, wasn't just clever coding, it was a completely different way of thinking about code itself.
So, to get inside that way of thinking, we have to start by meeting the tools. We need to look inside the C64's brain, the 6510 processor, and check out the digital workbench where all the magic really happens.
Okay, so think of the processor as having three hands. The main one, the most important one, is called the accumulator, or just A. This is where all the heavy lifting goes down, all the math, all the logic. The other two, registers X and Y, they're like helper hands. They're mostly used for counting things and just keeping track of where data is.
Now, this diagram shows a really fundamental rule of the road inside that processor. You can't just move a piece of data from register X straight over to Y. No way. Everything has to pass through that main hub, the accumulator. This forces programmers to be super deliberate, planning out every single step of their data's journey to save those precious clock cycles.
So you've got three hands, but what happens when you need to juggle more than three things at once? Well, you need a place to put things down for a second. And for that, programmers had this incredibly clever tool called the stack.
The stack is basically a temporary holding area. And honestly, the best way to think about it is like a stack of plates or maybe a Pez dispenser. You can only add a plate to the very top, and you can only take a plate from the very top. The last one you put on is always the first one you take off. This principle is called LIFO, last in, first out.
Let's see how that works. Imagine we want to store the letters P, R, and O. First, we use a push command to put P on the stack. Then we push R right on top of it. Then we push O on top of that. Now, when we want them back, we use a pull command. So which letter do you think comes off first? Yep, the O, because it was the last one in.
And this simple idea leads to some brilliant tricks. If you take the Serbian word for sample, probno, and you push each letter onto the stack, and then pull them all back, you get onborp. The word is perfectly, instantly reversed. This is an incredibly elegant and super fast trick in assembly. Trying to do the same thing in BASIC, that would require a much more complicated and clunky routine.
Now, alongside all this clever data management, speed was absolutely everything. And for the most common math operation of all, just adding or subtracting 1, assembly gave programmers these dedicated lightning-fast commands.
These commands are INC for increment and DEC for decrement. And they are hyper-optimized right at the hardware level. So instead of some multi-step addition routine, it's just a single instantaneous command. When you needed to count down a timer or move a character 1 pixel, this was the secret sauce to making it feel snappy and responsive.
But here's where it gets really fun and kind of weird. The C64's processor can only count up to 255. So what happens when you're at 255 and you add one more? It doesn't crash, it just wraps right around back to 0. It's a circle. And the same thing happens in reverse. If you're at 0 and you subtract 1, you jump all the way to 255. This isn't a bug, it's a feature. And clever programmers used it for all sorts of amazing tricks.
So, we've met the tools. We have the registers, the stack, the super fast math. Now it's time for the main event. Let's put assembly head-to-head with its simpler cousin, BASIC, just to see how massive the difference in efficiency really is.
The challenge couldn't be simpler. We're going to write a program that does just one thing: change the color of the screen border and the main background. It's a task that both languages can do easily, but the real question is, at what cost?
And here we have it. On the left, that's the amount of memory needed for the assembly program. On the right, the memory for the exact same task in BASIC. You don't even need the numbers to see the story here, do you? But just for fun, let's look at the numbers anyway.
The assembly code, it takes up a grand total of, get this, 9 bytes of memory. That's it! 9 characters worth of information.
The basic code, to do the very same thing, requires 100 bytes.
So let's be clear about what this means. For this incredibly simple task, the assembly code is over 11 times more memory efficient. When your entire world is only 64 kilobytes, a difference like that isn't just an improvement, it's the difference between a game that fits on the disk and one that doesn't.
But this whole duel isn't just about saving space. That incredible efficiency, it unlocks a level of control and speed that basic programmers could only dream about.
Really, the difference is best described as surgical precision. Writing in assembly is like being a surgeon, directly manipulating the hardware. Writing in BASIC, it's like trying to do that same surgery with bulky oven mitts on. You're just giving instructions to a translator, which then talks to the processor. Assembly is the processor's native tongue.
In fact, some of the most powerful tools in the toolbox aren't just inefficient in BASIC, they are completely impossible. I mean, just take a look. These deep operations like directly manipulating the stack pointer or saving the processor's exact state, they just have no equivalent in BASIC. These are exclusive tools just for the assembly program.
And this is why it all matters. This power and precision is what gave us the C64's legacy. It's what allowed for those fast-paced action games, those silky smooth animations, and all those instant screen-flashing hardware effects. It's how programmers could squeeze every last drop of performance out of the machine to create experiences that honestly should have been impossible.
So from those simple data transfers between registers, to the clever LIFO logic of the stack, to those lightning-fast increment and decrement commands, these were the fundamental building blocks. These were the secret ingredients that allowed developers to build entire empires in a space smaller than a modern icon file.
Which really brings us to a final thought. Today, we have programming languages that are unbelievably powerful and easy to use, but they kind of insulate us from the hardware, right? In an age of what feels like near infinite memory and processing power, you have to wonder, what have we lost by moving so far away from the machine itself? What kind of understanding disappears when we no longer have to fight for every single byte?